So in this video, we're going to talk about the factors affecting the preferential discharge of ions. So in the previous videos, you'll find that in molten electrolyte, we only have one cation and one anion. But in aqueous form, you'll find that it is totally different. Just give a very quick example. For example, in H2SO4 AQ. AQ stands for with water. So when you check the cation and anion in the solutions, you'll find that cation part will have 2H plus. But for the anion part, you got OH minus and SO4 2 minus. So in this case, you have to choose which one will preferential discharge. So in this case, we have some factors helping us to decide which one will have react while the others will not. So the first one will be the position in ECS. So if you remember, we'll just focus on these sections of the ECS sections. So this is good enough for you to have the exam, okay? Other than that, okay, normally they will provide you some statement telling you that which one is more, which is a stronger oxidizing agent, while the other one is a weaker one, or they will give you a section of ECS. So you can referring to the table that they given to you, then you can do that kind of questions. But basically, you have to remember this one. This one is most useful one, okay? So first of all, you have to identify which one is OA, which one is RA. So first of all, on the left hand side, so this one is the oxidizing agent, while the right hand side is a reducing agent. Remember, right hand side, okay? So therefore it is the reducing agent. So in this case, we can find that if you're comparing the oxidizing agent, the lower the position, the better it is. So in this case, we'll find that H plus, we see that Cu2 plus is stronger than H plus, is stronger than Na plus. In case if you got Cu2 plus or H plus in the solution at the same time, Cu2 plus will be the one who discharge. Okay, so the same things happen on the right hand side. So if you have OH minus or Cl minus, then you'll find that OH minus has a higher position, because this sign we're talking about RA, or have a higher position than Cl minus, then OH minus will preferential discharge. So this one will preferential discharge. Okay, so in the exam, what we're going to write, okay, statement will be like that way. Okay, so you have to write down, several things. So you have to tell me that hydrogen ion has a lower position in ECS than, because you're using ER, right? Than NaIon plus. So what means by that? That means that H plus ion is a stronger OA. So at the end, you use preferential discharge to describe, or H plus will preferential discharge. Sometimes the question is asking about why hydrogen gas will be produced. Then in that case, don't write something out echoing the questions. So at that time, then you may have to say, hydrogen gas will be produced. So it depends on the questions. So same thing happens for the anion part. So you have to say that they have a higher position in ECS than the other ions, and then that is a stronger, but this time it's a reducing agent, not oxidizing agent. So it will be like that way. Okay, so you may pause the video and write it down, okay, in your notebook. Okay, this one is very useful. Okay, and other than that, we're going to talk about the concentration effect. The second factor is the concentration effect. So do remember, okay, when we deal with electrolysis, okay, the electrolyte concentration is very important. Normally you'll see three of them: very dilute, or concentrate. So normally the very dilute one, we're referring to 0.1 to 0.5 m, things like that. Okay, 1 m we talk about 1 to 2 m, while concentrate normally we're referring to solutions more than 5 m. Okay, so if we say that it is a concentrated solution, then concentration effect may happen. But do remember, concentration effect only happens for these four ions, okay, not for this part, okay, only for this part. Okay, so in case we have concentrated NaCl, then you go Na plus, H plus, OH minus, and Cl minus. Okay, so in this case you'll find that, okay, we are a concentrated Na plus NaCl, so therefore normally will be OH minus stronger than Cl minus in normal case. But this is a concentrated case, so this is not correct. Concentrated case, Cl minus will be stronger than OH minus. So you can imagine just have more chloride ion around the electrode. So therefore this time it will be better to get to the electrode, and then they will lose the electrons in the process. So in this case, you will find that Cl minus will discharge, preferentially discharge, then OH minus. Okay, and then finally, but do remember in this case, okay, it doesn't apply to this part. Okay, it doesn't apply to this part. In this part, we still have H plus stronger than Na plus. The reason behind is Na plus is too weak oxidizing agent. Even it is concentrated enough, okay, or even it is in concentrate or situations, it's still not good enough to overcome the power of the NH plus. So this one blank page. Okay, and then we go to the concentration effect. Okay, so for this one, the statement is very easy. You just have to say due to concentration effect. Okay, and then chloride ion still use preferential discharge, or chloride ion will preferentially discharge. Okay, so in the question, if they mention why chlorine gas is produced, then you have to mention this statement as well. Oh, the last one, okay, is the nature of electrode. In the syllabus, you're going to have two special cases you have to remember. One will be Na plus. So you can see that Na plus actually is very, very weak. Okay, it won't be much more much more stronger oxidizing agent than H plus or Cu2 plus. But in some situations, Na plus will discharge. So that will be when mercury used as cathode. So there will be one special setup telling you that mercury will use as cathode. Mercury used as a cathode. At that time, Na plus will then receive electron and become Na. While this is the first example. The second example, okay, will be copper used as anode. So at that case, you'll find that the copper, this is the copper as an anode, or even you have OH minus, Cl minus around, okay, you'll find that OH minus and Cl minus will not discharge because it itself, okay, will be the one who losing electron. So at that case, Cu will then lose electrons, become Cu2 plus. Okay, so only Cu as anode, they will have such effect. So for writing it down, okay, that will be say Na plus ion will prevent discharge because mercury is used as cathode. While the other one, pay attention to the word Cu atom. Atom is not ion. Okay, so remember atom, not ion. So we prevent discharge because Cu is used as anode. So quick revisions. So there are three factors affecting the rate of the preferential discharge. First is position in ECS. So please spare like 2 minutes memorize this table. Second one will be the concentration effect. So remember, concentration effect only affect these factors, this area. And the third one, okay, will be nature of electrode. Nature of electrode, we got two examples. One is mercury as cathode. So this one will affect Na plus, while the second one will be Cu as anode. And then the Cu will then lose electrons and become Cu2 plus, while Na plus will gain electron, become Na. So that's all for this video. Okay, good luck. Bye bye.